All right, you ready? Everybody finish copying this down? All right, so last couple of weeks we learned how to solve one-step equations, and then we learned how to solve two-step equations, right? That's what we took our test on Friday. This, we're learning how to solve multi-step equations, so that means there's going to be more than two steps, right? One-step equation, we just had one step to our answer. Two-step was two steps until we found our answer. Now this just means we might have a few more steps, okay? But the way that we solve it is completely the same. Nothing changes. We just have a few more steps, okay? So the first step right here, we're using the addition or subtraction property of equality to get all the variables to one side, and then you also want to get all your constants to one side. Your constants are what? What is a constant? Just your numbers. So the numbers that do not have a variable with them. So that means that you want all your variables on one side of your equal sign and all your constants on one side of your equal sign, okay? We will only be using the addition or subtraction property of equality to do that, okay? So once we get all of our variables on one side and our constants on one side, then we can multiply or divide to solve for x, okay? So let's look at an example. We've got example 1. Remember, when we're doing equations, we are solving and checking. So don't forget to solve and check. You zoom up a little bit. All right, so the first example we've got is 7x equals 5x plus 4. Okay. So the difference here between our one-step and two-step equations is we have two different variables, or the same variables, but two different terms with variables. We're used to just having one x somewhere in our problem. Now we have two. But remember, our first step is to get those constants and variables on opposite sides of the equation. So if I have a 7x on the left-hand side and a 5x on the right-hand side, I want to move both of those, or one of them, so that they're all to one side. Okay. So I know that 7x is already over here and my constant is already over here. So I want to move this 5x to the other side. Okay. This is a positive 5x though, right? Remember, we're only using our addition and subtraction property to move them to the other side. So if I want to move this to the other side, I'm just going to subtract 5x from both sides. Okay. So we're not dividing. We're not dividing here. This is 5 times x, which normally we're used to dividing, right? To solve for x. But remember, we're not solving for x right now. We're just getting all of our variables to one side. So if I'm moving this over, that means I'm subtracting 5x from both sides. So when I do that, that means that these cancel, right? And it leaves me with 2x on this side. 7 minus 5 gives me 2, which is equal to, bring down my 4. Okay. So now my variable is on my left-hand side and my constant is on the right-hand side. So now I can solve for x. So how do I solve for x? We should know how to do this. This is what we learned last. Divide by 2 on both sides. Okay. Good. So then those 2's cancel and it leaves me with x is equal to 2. Okay. So once we get all of our variables and constants on opposite side of the equal sign, it's the same exact thing that we were doing all last week. Okay, we're just solving for x. Remember, we got to check it. I'm just going to go ahead and plug in my number for x instead of copying down my equation. Is that okay? Okay. So remember, if I'm checking it, I'm just plugging in 2. So that means I have 7 times 2 equals 5 times 2 plus 4. What is 7 times 2? 14. So that gives me 14 is equal to 10 plus 4. So I know my answer is correct. Okay. So don't forget to check your answer. Questions on example number 1? All right, let's look at another example. We've got 3x minus 2 equals x plus 4. No, because this one's a little bit different. So, as you notice here, I've got x's on both sides and constants on both sides, right? So, my first step, though, is still the same. I still want to get all my variables on one side and all my constants on one side. To save us a step, you want to kind of try to not have negatives. So that means you want to subtract your smaller number from both sides. Okay? Or if you have a negative, so if I had a negative 2 right here, I would want to add it to both sides instead of subtracting 4, because then that would give me a negative. Okay? So it doesn't really matter, but if you do have those negatives, it's just going to give you one extra step. You still can get the right answer. It's just a couple of extra steps. It's really unnecessary. Okay? So if I look at my x's and my constants, I can choose to move over whichever one. I don't have to do one first and the other second. But I'm just going to go ahead and do my variables. I just like to do my variables first. Okay, but it doesn't really matter. So if I have 3x and 1x, which one do I want to move to the other side, Andrew? 1x. My 1x. So if that's a positive 1x, how do I move it? Subtract. So I'm going to subtract x from both sides so that these cancel. And it leaves me with, what's 3x minus 1x? 2x. So I have 2x minus 2 is equal to 4. So I got all my variables on one side, but now I need to get all my constants on the opposite side. So if I do that, how do I do that?
Plus 2.
I want to add 2 to both sides. So it gives me 2x is equal to 6. Good. So this is exactly how we've been doing. We're used to this. So we're just solving for x. So that means we're dividing by 2 on both sides. So that gives me x is equal to 3. Am I done? No, I want to check it. So that means I'm just plugging in 3 for x. So I have 3 times 3 minus 2 equals 3 plus 4. What's 3 times 3?
9.
So that gives me 9 minus 2 equals 3 plus 4. And then what's 9 minus 2? So my answer is correct. Questions on this one? So we're getting our variables to one side and our constants to one side, and then you're just solving for x. Okay. We good? All right, let's look at example number 3. I've got 2x plus 3 equals 3x minus 2. Yeah, go ahead and do it. So everybody go ahead and try to do this one on your own. So that means everybody should be writing. right, what does x equal? 5? Everybody get 5? Good. X equals 5. So that means if I move my x's to one side, I want to subtract 2x from both sides.
I put your x equals 5.
Okay, that's the same thing. But you want to get rid of that 1 in your final answer. Don't leave that 1 in your final answer. And then that gives me 3 equals x minus 2, and then I want to add that 2 to both sides so that my constants are on the left and my variables are on the right. So that gives me x equals 5. And then when I check it, I plug in 5 for my x, and I get 13 equals 13. So I know that my answer is correct. Okay. Does everybody's work match mine? You messed up. Do you? At least you found out where you messed up. You can do that.
But I still got 5.
Yeah, that's the same thing, because that is a 1x. Yes?
I messed up twice and I still got 5.
Well, you must not have messed up too bad. Andrew?
I didn't know how to write the equation, but I knew what x equals before I even worked out the problem.
No, because this is a little bit of an easy one. You could kind of look at it and see what it equals. So. But I still want to see I want to see you show your work. Okay. Questions? All right, one more example, and then I'll let y'all get started on your homework. So maybe you won't have too much tonight.
Oh, homework.
All right, we've got 5x plus 15 equals x minus 49. All right, remember that I'm getting my x's on one side and my constants on the other. And I want to look at my smallest one, or whichever way that's not going to give me a negative. So if I want to deal with my variables first, I've got 5x and 1x. Which one do I want to move to the other side? My 1x. So that means I have to do what? Subtract x from both sides. So what does that leave me with? 5x minus x? 4x. So I have 4x plus 15 equals what? Negative 49. Don't forget that negative. So my x is on the left-hand side, so that means I want my constants to be on the right-hand side. So how do I get that 15 to go to the right-hand side?
Minus 15.
I want to subtract 15 from both sides. That gives me 4x is equal to what?
64.
Negative 64. Remember those integer rules. If you're doing this in your head, be careful because you're dealing with negatives. Okay. If you're plugging it in your calculator, you shouldn't have a problem. But if you're doing it in your head, you've got to remember those adding integer rules. Yes, ma'am? You could, but that would give you everything on your left-hand side, right? And then that would give you equals 0, which is fine. Then you would just have to move one of either your variable or your constant to the other side anyways to solve for x. So it's just one extra step. But you still would get the same answer. What is it? Negative 16? Good. I'm dividing both sides by 4. So that gives me x is equal to negative 16. Am I done?
No, you gotta check.
Gotta check it. So that means I have 5 times negative 16 plus 15 equals negative 16 minus 49. Five times negative 16? What's that give me? Negative 80. So I have negative 80 plus 15 equals what's negative 16 minus 49? Negative what? Negative 65. Good. So then negative 80 plus 15? Negative 65. So I know my answer is correct. Any questions? Do you think you're ready to do your homework? Classwork? Homework? Okay. Remember, there is one problem in your homework that has 3 B's, or 3 variables. So remember, if you have something on both sides that you can combine, so if you have like terms on both sides of the equal signs that you can combine, go ahead and combine your like terms before you solve for x, or before you start moving things to the other side. Okay? So your homework, classwork, is page 233, numbers 9 through 23, odd. Don't forget to solve and check. It's up there on the board underneath the agenda.